for this particular video, now this is the second video of a two-part video. For this particular video, I'm going to be going into more detailed practice in completing the square and explaining completing the square in greater detail. However, before going into this video, you want to make sure that you are confident in factorizing and expanding quadratic expressions of the form x plus d all squared, so for a quadratic expression that represents a d, as well as factorizing and expanding quadratic expressions which are a difference of two squares. So that's an x plus a value times an x minus a value. So let's have just a quick review. So at this particular point, if you were given a problem, expand x plus 10 or x plus 20 or x plus 7 all squared, you'll be able to expand that quite confidently. At the same time, if you were given a problem like one of these, x squared plus 10x plus 25, and you were asked to factorize it, you would look at this and you could factorize it the normal way. So you could factorize it by looking for the common factors and separating, breaking up the 10x term into two terms and so on and so forth. So you could factorize it the way that you would have learned to factorize it. But at this particular point, you want to first ask yourself, I wonder if that's a square. And if I look at this, I'll say, hang on, there's a 25 there, that's 5 squared. Well, that's interesting. 5 squared. Well, there's 2 5s makes 10. So I believe that this is going to be x plus 5 all squared, and you can jump straight to that factorization if you can recognize that pattern. So looking at this more algebraically, the example I have up here with x plus d all squared, whenever you've got a value, whenever you've got an x plus a term, and that is all squared, what that's going to expand to is the first term squared at the beginning, the second term squared at the end, and in the middle it's double the two terms multiplied by each other. And that comes, if you look at the expansion here, that comes from the fact that I'm going to end up with a x times d plus another x times d. So I'm going to have 2x times d, but that's where that middle term comes from. So that comes from a square. The other review is a difference of squares. So in a difference of squares, this is actually kind of similar. There's a similar pattern here in that it's the first term squared and the second. It's the first term squared and the second term squared that appears in the expansion of these two terms in parentheses. So when they get expanded, this expression gets expanded, we have the first one squared and we have the second one squared. The only difference here, there's no middle term because it cancels itself out, and also there's a negative there. So if you were to see a problem which would say x squared minus 25, you want to be in a position where you can look at x squared minus 25 and recognize immediately that that is very likely going to be x plus 5 times, and here's one down here, x plus 5 times x minus 5. And if I'm in an exam and I can see that and I want to take the shortcut, great, take the shortcut. But always double check it by, for myself, I double check it by re-expanding it again to make sure I get back to the original expression. So that's the review of where you want to be confident with at this particular point. I would recommend, if you've just watched the first video of this two-part video sequence, give it a few days and come back to it. You really want to lock that first video into your sort of medium-term memory. If you look at the first one and come straight to the second one, you're going to try to remember too much at once in your short-term memory. You want to probably come back to the second video after a few days and even go back and re-practice some of the problems in the first video to make double check you've got the right level of confidence. Okay, that all being said, I'm now going to dive into completing the square and we're going to do this step by step. This is going to rely on, the first thing we're going to rely on is the expanding and factorizing a square. So this is called completing the square because we want to take an algebraic expression and modify it, and we can modify it any way we want in this, but for this particular purpose, we want to modify it so that we are creating an expression that represents a square. So let me talk through the very first example. It's going to be a much simpler example. I'm going to talk through the very first example. That recording volume looks a bit loud. Hang on a second. Let me talk through the very first example, and I'll pause the video so you can attempt the next one, then I'll walk through the solution for the next one, pause, and keep going for each of them. So you get it up. I want you to take an opportunity, pause the video, and attempt the problem for yourself and then look at the solution and see if you got the right one. If you didn't get the right result, then if you didn't get the right result, then you want to make sure you get some extra practice before we move on to the harder problems. Okay, so x squared plus 2x. Okay, how do I turn that into a square? What do I need? Well, I remember the pattern that we saw. Whenever I had a squared expression, I had whatever the value was here, I had 2 times the value in the middle, and I added the value squared at the end. So if 2 times the value is 2, then in this case the value that I'm looking for must be 1. So I'm going to add 1, which is 1 squared. Let me have a look. So does that equal x plus 1 all squared? I'm going to test this by, I've factorized, so I've created an expression. That's my goal here, is I've created an expression which I believe is a square. I've then factorized the expression straight into a square, but I'm going to double check my factorization by re-expanding it. So that's going to be x plus 1 times x plus 1, which is going to be equal to x squared plus 1x plus another 1x plus 1 times 1, which is equal to x squared plus 2x plus 1. Excellent. So that result is where I started with the square I made. So I correctly completed the square by adding this particular term to this expression. So what I want you to do is, for this next problem, I want you to see if you can work out a term that you need to add to this expression, just like I did, and a term that will complete the square. Once you've tried to work out what that term is, I want you to then do x plus write down x, the factorized form of the square, which is x plus the term all squared, and then I want you to re-expand that and check you were correct. If you didn't get to the same result, try again. If you need to guess a few times to find the right term, that's okay. I'll give you a hint that this term is going to be somewhere between 1 and 20. I think. No, actually this term is going to be, sorry. Yeah, it's going to be somewhere between 1 and 100. Sorry about that. I probably should have given a smaller number for the second problem, but give it a go anyway. I'm going to assume you'll pause the video now, and then when you finish, you'll return. Okay, at this particular point, I've assumed that you've paused the video and you've returned. I'm going to talk through this one. So again, I'm looking for that same pattern, remembering that when I had a square that was expanded, the second term, my x plus that other term, I had twice that term in the middle here, and I had the term squared at the end. So if 16 is twice the term, then the term I should be looking for to complete my square is going to be 8. So I'm thinking that this is going to be an x plus 8 all squared, and in order to complete this square, to make it an x plus 8 all squared, I will need to add 8 squared, which is 64. Let me double check that now. So that's going to be x plus 8 times x plus 8. If I expand the brackets, that's going to be x squared plus 8x plus 8x plus 64, and that's going to be equal to x squared plus the two x's combined to form 16x, and the 64 remains. And when I expanded my square, I got back to the original expression that I amended. So I've correctly completed the square for this particular term. This next one should be a little easier, although it can be a little deceptive. When we start seeing these round numbers, sometimes we try to think ahead and we jump ahead and we can make a mistake. Let's see how you go. So pause the video now, and I'll see you when you get back. Okay, I've assumed that you've paused the video and you've attempted this and hopefully been successful in working out how to complete the square. You've done that by working out a number, an extra term to add to this expression, putting that term into a square, and re-expanding the square to see if you got back to the original. If you didn't get it right, have another go. Pause the video and have another go, and then come back once you got it right. If you frustrated and you've given up, that's okay. Come back and I'll show you how I've done it. These problems are going to get progressively hard though. So if you still struggle, if you're having difficulty working out how to complete the square now, I would actually recommend getting onto somewhere like Khan Academy and looking at completing the square tutorials in Khan Academy. It's a fantastic resource. Okay, so returning from your pause now, x squared plus 10x. So half the middle term is going to be 5. So if half of 10 is 5, I need to add 5 squared to complete the square. So in other words, I'm thinking in my head this is going to be x plus 5 all squared. I'm going to add 25 to convert this expression of x squared plus 10x to make it a square. Now, by the way, this particular practice I'm doing, and I probably should have highlighted this beginning, I'm not asking to balance any equations, I'm not asking to keep this correct, I'm just asking to complete the square. We'll deal with balancing the expressions and equations later. Right now we're manipulating expressions, we're not balancing equations. In case anyone was curious, they might have added 25 and subtracted 25. The reason I'm not doing that is because I'm not trying to preserve the value. Alright, let's go through this quickly. So it's going to be x plus 5 times x plus 5. That's going to be equal to, I'm going to jump back here for screen space. It's going to be x squared plus, at this point I'm getting pretty confident with this. I can see I'm going to have a 5x and another 5x. Two 5x's are going to give me 10x and add 25. However, I'm really confident with these, so I can take that shortcut. If you want to write it out in the 4 terms and then collect them, that's perfectly good. You need to do what makes you successful. Okay, let's do this next one. This is a trickier one now, so pause the video and come back once you've attempted this. Okay, so this particular one relies on your, I've assumed you come back and you've had an attempt at this, at completing the square here. This is a tricky one because we're dealing with fractions. However, the process is still the same. So this may test your confidence with fractions. It's very, very common because we often sometimes jump to decimals a bit too early and rely on decimals a bit too much and patterns of decimals. It's very common for students in up to 11 and 12, even up to year 12, even at university level, to be a bit uncomfortable. Even at university at an engineering level, to be uncomfortable with fractions. So, x squared plus 9 on 5x plus, I need to add a term. So here, to form my square, remember to complete the square, I need to find whatever this term is, and I need half that term. So I need half of 9/5. Well, half of 9/5, if I know that's going to be 9/10, but just to show off on the side, if I had half, where's my razor? There it is. So just off the side of here, I'm just going to jot down, I want half of 9/5. That's going to be, well, when we multiply fractions, we multiply the top and the bottom. So that's going to give me 9 on 10. So I'm going to add 9 on 10. Now, when completing the square, it doesn't matter that my expression is fully resolved. What I mean is it doesn't matter that I've got, you know, improper fractions, proper fractions, rational numbers. I'm going to be a little bit lazy here and say, you know what, I'm just going to add 9 on 10 all squared. Because remember, whatever the half this term is, I need to add that squared. I'm not really worried right now at working out what that is. Although that's going to be 81 on 100. That's not really the focus at this point. Actually, no, you know what, I'll continue with that. So, and I'll show you what that looks like. So when I expand this, oops, sorry, that should be all squared. So that's what I suspect my square is going to be. To complete x squared plus 9 on 5x, to make it a square, I need to add the term 9 on 10 all squared. So that's going to be x plus 9 on 10 times x plus another 9 on 10. That's going to be equal to x squared plus 9 on 10x plus another 9 on 10x, and because when I added it to the previous one, if you did 81 on 100, that's fine as well. I'm just going to go, it's going to be 9 on 10 times 9 on 10, which is 9 on 10 all squared. So I'm just going to be a little lazy there. Okay, so that's going to be x squared plus, Okay, I've got 9 on 10, I've got 9 on 10. Well, they've got the same denominator. When I'm adding fractions, the same denominator, I just get to add the numerator. So that's going to be 18 on 10x plus 9 on 10 all squared. I'm not going to expand, I'm not going to get that to a proper fraction by getting rid of the square. I'm just going to keep that there. Okay, so I need to simplify 18 on 10. So, because they're both even numbers, so 18 on 10, well, if I divide the numerator by 2 and the denominator by 2, I end up with 9 on 5. So that gives me x squared plus 9 on 5x plus 9 on 10 all squared. And voila, when I completed my square, when I completed my square with x plus 9 on 10 all squared and I expanded it, that square came to the same expanded result as I began with when I completed the square for the original expression. So I got that correct. I'm excited about that. Okay, last one is to complete this particular square, x squared plus 12.3x. Okay, you can pause the video now. Alright, I'm going to assume you're back. I'm going to go through this one a little bit quicker. So to complete the square, I need x plus half whatever this value is. So half of 12.3, it's decimals, that's going to be 6.15, 6.15 all squared. Alright, if it's 6.1, if half that value is 6.15, to complete the square, I need to add up over here 6.15 all squared. Yes, I do have a calculator handy. I'm actually going to fully resolve this one. It doesn't matter, I could just write, actually no I won't. You know, it's okay to be lazy as long as you're right. What I mean by that is writing 6.15 squared or writing 36, 30 to 40, whatever that works out to be, it's still the same thing. It's just represented in two different ways. So I don't need to actually calculate that at this particular point in time. Maybe later I would. But that's going to be plus 6.15. Let's see if I'm correct. So when I expand the brackets, I end up with x squared plus 6.15x plus 6.15x plus 6.15 squared. That's going to be x squared, 6.15 plus 6.15. The 0.15s will add to give me a 0.3. The 6's will add to give me a 12. So that's going to be plus 12.3x plus 6.15 all squared. That matches the expression that I completed when I completed the square. So this expression will factorize to x plus 6.15 all squared in order to complete the square. Okay, now we're going to change it a little bit further. So in these set of exercises, what we were doing is I was giving you an expression and you were trying to work out how you complete that expression to form a square. For this new set of expressions, we're going to insert a square into the following expressions. I'm going to demonstrate that on the very first problem. In other words, this time, I don't want to change the value of the expression. I'm going to modify the expression so that there is a squared quadratic inside the expression. So, I'm going to demonstrate on the very first one. So I've got x squared plus 4x. So when we're completing the square, or if I'm going to insert a square inside an existing expression, I only care about the 4x. So remember before, I had to add, so if I just look to complete the square, I'm going to have x squared plus 4x. That's the part of the expression I care about when I'm forming a square. To form a square, I need to add half of the term in front of the x, so half, I have to work out what number is going to be 2 times something's going to give me 4. So that number is going to be 2, and I need to add that squared. So that's going to be plus, so half of this value, I'm going to add that squared, so it's going to be plus 2 squared, just like we did in the previous set of exercises. However, I'm inserting a square into an existing expression. So I have to preserve the existing expression. So I've got plus 1. But see, I've added this 2 squared. I've modified the value of the expression. So I need to cancel that 2 squared out by subtracting 2 squared. So what that looks like, I'm going to tidy up, but I want to keep my square inside the expression. So by tidying this up, this is going to be x squared plus 4x plus 4. That is my square here. That is my square plus 1 minus 2 squared is 4. So 1 minus 4, that's going to be minus 3. So I've now modified the expression to include a square in it. So that square is going to be x plus 2 all squared minus 3. Now I've inserted a square into this expression and I've factorized it now. I didn't actually ask in the original problem to factorize, but I think it's good practice to do that factorization while we're here. I'm now going to double check my work by expanding the factorization and collecting all the like terms to see if I get back to the original expression. So that's going to be equal to x squared plus x squared plus 4x plus 4 minus 3, that's going to be equal to, so the plus 4 and minus 3 will give me plus 1, so it's going to give me x squared plus 4x plus 1. Okay, I'm back to the original expression. So I've taken, let's walk through what I just did. I've had the original expression. I then modified the original expression by adding an extra term that will give me a square. The term I added was 2 squared. I chose 2 squared because it was half of 4, because that's what I needed to create a squared expression. But to maintain the value of the expression, so I didn't alter it, I had to balance it out by subtracting a 2 squared at the end. By inserting that, by creating the square expression, I could then factorize the original expression, so x squared plus 4x plus 1. I could factorize it so that it is x plus 2 all squared minus 3, and I double check my answer by re-expanding it. Now, why do we do this? We're going in circles here. We're just modifying the equation. Oh, great, we've put a square in the equation. What does that really mean? Well, we haven't covered it currently. I haven't covered it currently in my classes, but later on we're going to be talking about the turning point form of a quadratic when we're graphing quadratic. This particular expression here, x plus 2 all squared minus 3, actually produces a pattern that tells you where the point is on a quadratic. But really, the reason we do this, it's really good practice to be able to rearrange algebraic expressions into any sort of form, because different forms of an expression can make you see patterns that aren't obvious. For example, if I showed you these expressions up the top here, if you just saw x squared plus 6x plus 9, if you just saw that, you're not seeing any particular pattern. But, well, without practice, if you factorized it and worked out, well, hang on, that's x plus 3 all squared. Well, that's actually a much tidier way of representing the original expression. So there are reasons we may want expressions in a factorized form or an expanded form or anything in between, and as you get into more complex mathematics, these looking for these patterns is going to helps you solve some really complex problems. Okay, so you're welcome to pause the video now. I've got the example above. Have a go at inserting a square within this expression, x squared plus 10x plus 4, and I will then go through and walk through it, so you may pause the video now. Alright, I'm going to assume that you've returned from pausing the video, and I'm going to go through this fairly quickly and see how we go. So I want to complete the square. So when I'm completing the square, I'm trying to think of what x plus something squared is going to give me the first part of this expression, x squared plus 10x. The reason I'm ignoring the plus 4 is I just don't want to complicate it at the moment. I will deal with the plus 4 later. So x squared plus 10x. Okay, to complete the square, we actually did one of these earlier, I'm pretty sure, but half of 10 is 5. So I need to add 5 squared, which is 25, in order to create a square. And the square is going to be x plus 5 all squared. But I've just added 25 to this term, this expression. I need to take that 25 away so that I don't change the value, and don't forget that plus 4. So I can't alter the overall value of the expression, the quantity that the expression represents. So I need to balance that out. By doing that, I can now factorize this and tidy it up as to x plus 5 all squared, because that is my square there. So great, I've inserted a square into the expression, and I'm just going to tidy up the numbers at the end. So it's going to be minus 25 plus 4, that gives me minus 21. I have completed the square, and I've rewritten this first expression, x squared plus 10x plus 4, I've rewritten it into another form. Again, right now I can double check my answer very quickly by expanding it. I'll get x squared plus 10x. By expanding this, I'll get x squared plus 10x plus 25. 25 minus 21 is going to give me plus 4, so I can see that immediately. You're welcome to check that, but I'm just looking at the length of this video. I've gone on long enough. I want to start wrapping it up. Okay, pause the video, have a go at this next one, and then I'll show the solution. Okay, this next one was a little tricky because we're going to be dealing with an improper fraction. We're not going to deal with whole numbers. So let me show you what that looks like. Equal. So I want to create a square from the x squared plus 9x. To create a square, I need half the middle term all squared. So I'm going to add 9 on 2 all squared. Because I've added 9 on 2 all squared, I need to take that away. And don't forget the plus 4. So I've now modified the expression, so I have a square within the expression. That square is going to be x plus 9 on 2 all squared. Minus, yeah, let's do it. So that's going to be 81 on 4 plus 4. 4 is 16 on 4. So I've just taken the plus 4 and converted it into quarters. Tidying that up, that's going to be x plus 9 on 2 all squared minus 81 plus, negative 81 plus 16 is going to be, now my head's not working very well at the moment, so I'm just going to guess that should be 565, I believe, minus 65 on 4. Hopefully that's correct. I should double check. I can't allow, as a maths teacher now, I can't allow myself to use that calculator. So I'm just going to double check this. I won't let you listen to that before I continue. Okay, I just double checked. I didn't use a calculator, I was just doing the numbers in my head and thinking out loud. Alright, excellent. Now, these next two are more complex than the previous ones. Everything we've done so far to complete the square has been on a monic quadratic. In other words, we've only ever had a hidden number 1 at the beginning. For these particular ones to be successful, what you need to do is, when completing the square, we're only dealing with a monic quadratic. Because the patterns that we've looked at before have only ever been x plus something all squared. To convert this into, I'll give you a tip. Actually, if you want to have a go at this without the tip, you can pause the video now. Okay, I've assumed if you had to go without the tip. Here's the tip, by the way, for everyone else. The tip is video. Alright, I'm going to talk this one out loud. That's supposed to be squared. Ooh. You know, I have made that mistake a few times. Sometimes I'm thinking, did I make that mistake before? No, I didn't. Excellent. I have made that little slip up. Okay, so that's going to be, my square is going to be x plus 3 on 2 all squared. And if I've factorized the first 3 terms of the expression into x plus 3 on 2 all squared, and if I expanded that, I should get back to x squared plus 3x plus 3 on 2 all squared. I'm going to take 3 on 2 all squared is going to be 9 on 4. I'm going to take 9 on 4 away, and I mustn't forget my plus 4 at the end. Actually, I'm going to write that plus 4 as 16 on 4. So that's going to be equal to 2 outside of x plus 3 on 2 all squared minus, that's going to be minus negative 9 plus 16. That's going to give me plus 7 on 4. Now, this is not really a tidy way of leaving it. I'm actually going to put the 2 back in and distribute the 2 across each of the terms in the middle, because that's going to be a lot tidier. So it's going to be 2 outside of x plus 3 on 2 all squared, plus, if I did 14 on 4 and then simplified it, that'll give me 7 on 2, or 3.5 if you were using decimals. Okay, that's that solution. I'm now going to go through the next problem, the same approach. It's going to be more complex fractions. Pause the video now and have a go, and then come back to me when you're ready. Okay, so I'm now going to, this is a really long video. I'm going to complete the square. I'm going to take my 3 out, so I've got x squared equals to, I might just zoom that in a bit, hopefully I'm not. Okay, make sure I give myself some room. Okay, 3 outside of, I need to complete my square, so I need half the middle term, so x squared plus 8 on 3, that stays the same, but I need to add half that middle term all squared, so that's going to be 8, well actually you know what, I can write that as 8 on 6, or I'm halving the middle term, I can just halve the numerator, so that's going to be 4 on 3 all squared. You could have written that as 8 on 6 all squared as well, minus 4 on 3 all times by 3, yep, 21 ninths, 3 outside of, keep my square, x plus 4 on 3 all squared, minus negative 16 plus 21 is going to give me plus 5 ninths. Alright, that wasn't too ugly. I'll put that 3 back in there because it's that form, in the current form, it's not very tidy. So 3x plus 4 on 3 all squared plus 15 on 9, or I can go 5 on 3. I need 5 on 3. Okay, there we go. Alright, so did I put some more? Okay, so so far we have only been using, and this is probably a really good time to pause and just, you know, come back to the video later. I might even make a third video, because to actually fully factorize an expression, we've only converted this into turning point form. We haven't actually fully factorized a lot of these expressions, and to fully factorize it, we need to recognize, so we'll use the same problems we have already, and we're going to now, with the same problems, we're going to fully factorize a problem. So we've completed the square, which put it into turning point form. In other words, what that format is I've got my square in the middle here, but I've still got this term on the outside. This can actually be factorized even further, and I'm going to demonstrate using the same problems. Let me just copy this. I'll just set up this next set of practice, and then I'll come back. While I copy these, by the way, what you want to, I need to model an example. I'm going to model an example up here. Nope, don't worry about me. I would like to edit this out, but I do not have time. Okay, so for this particular problem, we're going to now factorize these 3 expressions fully by completing the square. So we can use completing the square, but we also have to recognize sometimes when we complete the square and we have it in that turning point form, we actually have a difference of 2 squares. Let me demonstrate on the first one, and then you can practice on the next 2. So if we recall, that became, I'm actually just going to take a sheet, that became x plus 2 all squared minus 3. So that became x plus 2 all squared minus 3. Now, excuse me. So that became x plus 2 all squared minus 3. But this is not fully factorized. I've got a square inside the expression. I want to factorize this even further. Now, this is a simple one. You don't have to complete, like, I would expect a number of people to be able to solve this without completing the square. Alright, so to factorise this further, just for the practice sake, let's just say let a equal x plus 2. I'm going to use substitution to simplify the problem. So that's going to be a squared minus 3. Remember the difference of two squares. So the difference of two squares, which we had right at the top here, if I have a value, if I've got a value squared minus a value squared, that will factorize into x plus the value, the root of x plus the value times x minus the value, or the term, I should say. Where am I? There we are. I'm having a technical issue. Just let me pause. So I was just saying, it's going to be the first value minus the square root of the other value. Now this is actually not the simplest one. I probably should have come up with a easier problem. So this is going to be, so this one you would probably have to have resolved using the quadratic formula if you weren't using completing the square. But this will work out as the square root of 3. A plus the square root of 3 times a minus the square root of 3. It's not the best way for me to have instructed this. I just kind of made up these numbers and went with them. So, in other words, if we have a squared minus b squared, it's going to be a minus b. Well, if b squared is 3, then b is going to be the square root of 3. And I'm just going to leave it as the square root of 3 for the moment. So what I've done is I've factorized this expression further by recognizing that I've got a difference of two squares. But remember, I said that was x plus 2. So that's going to be x plus 2 plus the square root of 3, and x plus 2 minus the square root of 3. And now I have fully factorized this expression. If you work that out on your calculator, the square root of 3 is like 1.4 something. No, that's like square root of 2, maybe 1.4 something. Add 2 to that. If you put this through to the quadratic formula, you should get the same results for x, for the roots of the equation. You will note though, however, if you put this through the quadratic formula,